I'm Anil Kumar. Welcome to my series on probability. Now, this video is very special for all the students who will be appearing for GCSE. Now, the very first shot which we looked at is actually a dream for many high school students who want to soar high above and are looking for a very bright future. But what is the probability of getting there? That's a big question, right? With the help of this video, we'll try to answer a portion of it. What have I done here? I've actually included your major topics. I've also included the previous test questions and some of my questions. Combination of these two should give you what you need. So we'll talk about compound events, dependent, independent, tree diagrams, Venn diagrams, formula-based probability equations, and probability with complements. Now, in case you have any questions about this video, you can always contact me on my email address, which is given right there. Now, this is for level 9, or I'll also provide you with a link which will extend this topic to A and A plus level, so much higher level, since I have many playlists for university level students on the topic of probability. Okay, so let's first talk about compound events, right? So compound events will take event A, and followed by event B. So whenever we have, I should say, two or more, correct? Normally we'll restrict ourselves to just two events, right? So then we say it's a compound event. You'll also come across the terms which will say replaced or without replacement. So normally in your case, when I say replaced, then in that case, more of the time it will be independent events. Means things don't really change when you replace what has been taken away, so it remains independent. But when we talk about without replacement, then definitely it is dependent. So dependent or independent means what? Well, dependent or independent on what happened earlier, right? So dependent on what happened earlier. Right. So sometimes, let's say we have 3 red balls and 4 green balls, and if I take one and don't replace, the probability of picking up red or green next time changes. So it is dependent on the previous event. You got the idea, great. So with these basic ideas, we will actually take a few examples. I think you have understood all this. Tree diagrams are simple, which you have seen something going like this, right? So maybe further, correct? Now, tree diagrams give you a visual look of probability and it makes things very simple. So my suggestion is that if you think there's a lot of complexity in this situation, whether it is a dependent or an independent case, tree diagrams can really help. We'll take a few examples from your own previous test papers regarding this. Now, talking about Venn diagrams. So let me give you a base of Venn diagram. So a Venn diagram normally should be drawn within a rectangular box, correct? Now, in this box, we are going to always make, since we're talking about dependent events, we'll always make 2 circles, correct? And we'll say that everything which is corresponding to event A will be represented by one circle and B by the other. So in this case, the portion which is common to both, that will be referred to as A intersection, this is intersection B, right? Which means A and B. Do you understand? So that portion right in the center will represent common to both, intersection B. Right? Let's understand a few more terms here. Since I've also introduced to you complements, which is not seen in most of the questions for GCSE level 9, but as you move to A and A plus, that will become very important, right? So if I have to shade here, complement will be like this, right? So if I write this, that means complement of B. Okay, so let me make another diagram to illustrate complement. Now these are important issues, right? So it's better to go through them before we get into our questions, which will be relatively simple and straightforward. Now, let us say in this particular Venn diagram, we have A and B, and if I have to represent complement of B, that means not B, right? So everything apart from B, that becomes complement. Is that clear to you? Not B. Do you understand? So that becomes not B. You get my idea, right? So that is what complement is. And if I have union, let's talk about union also, and then we'll move forward. These are some important concepts which will help us to move forward. So if I say this is A and this is B, and if I write here what is A union B, right? So what does that mean? Well, that means the combination of A, right? And that also means combination of B also, right? So let me, combination of B. You see that part. Now, as soon as I colored B, you did notice that this portion was shaded twice. So that is key to understand that really means number of elements in A plus everything which is in B, but take away number of elements which are in intersection of A and B. Because we counted this twice, right? So introduce you another new term. That means number of elements, right? So in probability, this number is very important, right? So that means number of elements. Okay, then what are elements? Elements are everything within a set, okay? So we'll not go further than this. Fine. So I hope this concept is absolutely clear. You understand what is the intersection of two, which is common, right, to both of them. What is not in B means outside. So the combination of B plus not B, I wrote is a universal set. You understand. This will be called universal set, the whole thing. So if you include B and not B, it is called the universal set. Sometimes we denote it by S or some other symbol. Okay. So these are the terms which we'll be utilizing. And now let's take examples to understand how to solve probability questions which are relevant to you for GCSE. Okay. So from the format and the layout of this question, I think you must have guessed it. It comes from GCSE, right? So let's look into this question and try to understand how to solve this. There are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 4:1. Two counters are removed at random. The probability that both the counters taken are red is 22/35. Work how many blue counters are in the bag. Correct? Now, we have only two kinds of counters here, red and blue, right? So we're talking about red counters and blue counters. Second, we are given that their ratio is 4:1, right? So 4 red and 1 blue. So whenever it comes to a situation like this, and we're talking about probability, we should know what is the total sum, right? So we'll write total here, right? Total is the denominator part for us, correct? Very important. So in this case, the total will be 5. So if there are 5 counters, 4 are red, 1 is blue. Okay. But it could be a multiple of 5. We don't know exactly how many there are. So we'll say let them be 5 times x. In that case, red will be 4 times x and the blue will be 1 times x. Clear? So that is our base to start with. You get the idea, right? So that is how we are going to begin with, right? So imagine there are 5x counters, correct? In that case, 4x are red and x are blue, right? Since work out how many blue counters are in the bag. So x is our blue counters in the bag, which we need to figure out, right? So that is the number we are interested in finding. Does make sense to you? So that is how we'll actually begin with our question. Now, for this question, we could go direct without a tree diagram also. But since I want to, ensure that you understand what tree diagram is, we'll actually start with the tree diagram. Now, when we say 2 counters are removed, right? 2 counters are removed at random. Now, obviously, 1 will be removed first, right? So let's talk about removing one of them first, which could be either red or it could be blue, right? So it could be either red or it could be either blue. Now in a tree diagram, when you show these possibilities, you have to write down what is their probability, right? Then kind of becomes complete. Now clearly, total is 5x and the number of red is 4x. So this ratio here is 5x comes in the denominator, which is the total, and 4x for red comes in the numerator. Now since x and x cancel out, you could also write this as 4 out of 5. Is that clear to you? Right? Now as far as the blue is concerned, you have x of them out of 5 of x. So just as we did for red, it is x over 5 over x, which is basically equal to 1 over 5. Is that clear? So we have already drawn 1. Now it says what? The probability that both counters taken are red. Now imagine, if you take out 2, that means no replacement, correct? So in this case, we're talking about no replacement. So it is dependent on what happened earlier, right? So this is a case of dependent event because it depends on what happened earlier. So the further probabilities are not going to remain same. You get the idea, right? So that means it is dependent, right? Okay, so let's continue. Now what happens? Now again, if I am trying to take another counter, there are again 2 possibilities. It could be red or it could be blue. Same is the case with blue. It could be red or it could be blue. Clear? Okay. Now let's look into this probability, whether it is red or blue. What should be the probability of each event for the second time? Now, if I have already taken out 1 red, I got 1 less, right? So the number of red are 1 less than 4x, and even in the total, 1 less than 5x. Does it make sense to you? That is how we get the probability of the second event, which is followed. In this case, we'll write this in another way, which is probability for R to happen, if already R has happened, do you see that? Is equal to product of these 2, which is 4 over 5 times 4x minus 1 over 5x minus 1. So that kind of completes our diagram. I hope this concept is getting clear, right? I'm taking my time to explain you the very first example since That will open up all the gates for the coming examples. Correct? Now for B, you took out red, so we still have x of these kinds. But the total has decreased by 1, so it will be 5x minus 1 in the denominator. And the probability of getting blue when red was taken in the first case will be 4 out of 5 times x over 5x minus 1. Is that clear to you? Perfect. No problems. Correct. Now with that concept in mind, you can actually pause the video and write down the probabilities for red after blue and blue after blue. Correct? Okay. So let's continue. Here for red, we did take out blue earlier, so we already have 4x red. So it is 4x over 5x minus 1. So in the second case, 5x minus 1 will be in your denominator. Perfect. Now since you've taken out blue, second blue means x minus 1. Right. So now we get our probabilities. Probability for taking out red when blue was earlier taken out is 1 out of 5 times 4x over 5x minus 1, and the probability for blue after blue is definitely 1 out of 5 times x minus 1 over 5x minus 1. Is that clear? Now let's look into the last part of this question, which is the probability that both counters taken are red is 22. So that means we are given here two reds, right? So probability of two reds, both are red, is how much? Is 22 by 35. That should give us a condition to solve. Does it make sense to you, right? So that is very helpful statement, and it tells you what to do now and how to find our x value, correct? Now in our case, if you compare the very first leg of this tree, tells you both red. And we know for both red, it is 4 over 5 times 4x minus 1 over 5x minus 1, and that should be equal to 22 over 35. Does it make sense to you? Perfect. That is equal to 22 over 35. Clear? That is extremely important, correct, to understand? Right. Now at this stage, we could actually simplify this a bit and then move out. So let me simplify. 5 goes 7 times in 35. Is that clear? Correct? And this 4 goes 2 times, and that becomes 11 times. So we have something like this written here, which I could write as, let me rewrite this. So I can write this as 2 times 4x minus 1 over 5x minus 1 equals to 11 over 7. Is that clear to you? Now we will cross multiply and simplify to get our result. It is always better to work with smaller numbers. I could have cross multiplied right there, but then we are working with very big numbers, correct? So let's cross multiply. So we get 14 times 4x minus 1 equals to 11 times 5x minus 1. So that gives you 4 times 4 as 16, right? And 1 there. So 4 times 1, 4, and 1, 56. X minus 14x equals to 55x minus 11. Now bring the x's together. So we get 56x minus 55x equals to, we'll take 14. Sorry, this is not x here. We'll take 14 on the right side. So 14 minus 11. So clearly that is x equals to 14 minus 11 as 3. Is that clear to you? See, without calculator, we are easily able to solve this question, right? Now what? What do you need to figure out? Work how many blue counters are in the bag. So we started with x blue counters. So we have our answer right there. There are 3 blue counters. Does it make sense to you, right? So that is how you can actually solve this question, right? Now, let me extend this question, right? So if I have to ask you this question, let me say this is question number 1b for you, right? And this is my question number 1a. So what is my question? I want you to calculate the probability for either a blue or a red, right? So it could be either way, first blue or second blue, first red or second red. So I want you to find the probability of a blue and a red, you could say, right? So either way. So that is what I want you to calculate now, when we clearly know the value of x is 3. Perfect. I hope you understand this question, right? So it doesn't really matter. Or you could say probability of a blue and red. So we are taking out two counters and I want you to be of blue or red, or I could also frame this as the probability that the counters are of different colors. Does make sense to you? So probability questions could be twisted and written in so many different ways. So if I say, well, I am taking out two counters and I want the probability that they should be of different colors. That means what, right? So basically what you're going to do here is substitute the value of x, add these two, correct? So, right? So here what do you get? You don't get two reds and two blues. You get either a blue or a red or a red or a blue. So that will be your answer. Does it make sense to you? So I hope with this very first example, you understood how to make a neat and clean tree diagram, writing probabilities for each and every step, and then working out with the given conditions and solving a question. Let's move on and take the next example now. So here is the second question, again from your previous test papers. Let us see how to solve this one. There are 5 red counters and y blue counters in the bag. So again, we are talking about the red and the blue counters, but we are given that they are 5 and y this time. Correct? So these are red and these are blue counters. So immediately write total. Total is 5 plus y. Peter takes a counter from the bag at random. He puts the counter back into the bag. So they remain always 5 plus y, right? So it's a case of independent events. Peter then takes another counter at random from the bag. The probability that the first counter and the second counter is red, that means both red. So we're looking for both red. So we're looking for this probability where it is red after red. Do you understand? So when we say the probability that the first counter and the second counter is red, that means red after red, is 1 over 9. Work how many blue counters are there. We have to find the value of y for blue counters in this particular case. So you can actually pause the video, but I'll still like you to first sketch the tree diagram, correct? So let me quickly this time make a tree diagram. And so we have two possibilities, one with red and the other one with blue, right? So first case, we could get red or blue. Now, probability for red is, since there are 5, and the total is 5 plus y, correct? As far as blue is concerned, it is y over 5 plus y, correct? And now again, when we take out with replacement, so this is with replacement, correct? So total remains same. So whatever you took has been placed back into the bag. Perfect. Now again, when you take out, it could be red or blue, right? So it is red or blue. The probability this time will be how much? Do you see? It remains the same because there's same number of counters. So this is again 5 over 5 plus y, and this is y over 5 plus y. So what you see here is that nothing changes. So they are independent events. So let me call them as independent events. So now you understand what I was trying to say here. So for red, it is 5 over 5 plus y, and for blue, it is y over 5 plus y. Correct? Now what are you given? The probability that the first counter and the second counter is red is 1 over 9. So that is the path which we are going to follow, right? Both red means you follow this path. So when you follow this path, what do you get? You basically get here that they get multiplied. This is with AND condition, right? So we write this as probability that we are getting red and then red, right? So it is a condition of AND. So whenever there is AND, we just multiply them. So we'll just multiply them. So we get 5 over 5 plus y times 5 over 5 plus y, and that is equal to 1 over 9. That does make sense. And we just need to solve this one. Correct? Now to solve this, since we know these are same things and this is a perfect square, a better solution which should come to your mind is 5 over 5 plus y whole square is basically equal to 1 over 9. So you know square root it. So when you square root it, you get 5 over 5 plus y is equal to 1 over 3. Well, clearly, I will not write plus minus 3, should I? Right? Should I or should I not? We are doing square root, right? So we're talking about probability. We are working with positive numbers, correct? So it normally would be, let's make a note here, right? So we do square root. So square root of 1 over 9 will actually be plus minus 1 over 3, correct? But we are taking only positive values, since you could take both, right, and work out your example. So at present, I'll leave it open. So let's say we write this plus minus. Is that clear to you? So what I did was, I first squared and then I did square root, correct? So when you do square root, you get 5 over 5 plus y equals to plus minus 1 over square root 3. Perfect. Now let us solve it. Easy. So those were very simple steps to begin with. Now it gets complicated. So we'll just cross multiply, correct? So we get 5 times 3. Let me write 3 times 5 equals to 5 plus y. So that gives you 15 equals to 5 plus y. And that gives you y equals to 15 minus 5, which is 10, right? So we got the value of y as 10. Does make sense to you? It works, right? So if I write y as 10, we get 5 over 15, which is 10. Correct? So solving was much simpler. We got y as equal to 10. Well, these are our blue marbles, right? Blue chips, correct? So, okay, let me write down our answer here, which is how many blue counters are in the bag? There are 10 blue counters. Is that clear? So that is much simpler. So kind of an important step here is not to be, okay, you could have done square and then complicate this issue, but this is simpler. When you see it is kind of same thing, square and square root, get your result. Perfect. Okay, let's move on to the next example. Here is another question from your list of question bank. There are 5 red counters and X blue counters. So we'll begin with what we started with, red and blue, right? So that is what we have, and we always want to write what total is. Total is add them up. So we get 5 plus X. Is that clear? Right? So we have red and blue and total. Now this time I'm not going to make tree diagram, right? So I'll suggest you draw tree diagram. Is it okay? So let me show you how without tree diagram we can do it, right? That's the whole idea. So there are 5 red counters and X blue counters in a bag. 2 counters are removed from the bag at random. The probability that both counters are red. So we're talking about probability that both are red means red after red. Do you see that? Is given to us as 5 over 33. Does it make sense to you? So that means That means this statement, that probability that both are red. Is it okay? Red after red. So now you understand, correlate with what we did earlier about the tree diagrams. So first one red. So that is the scenario. First one red is 5 are red. Total is 5 over 5 plus x. Multiplied, because this is and, right? Both are red. And this and that. So now once you take away one of them, once you take away minus 1, you're left with how many reds? You're left with 4 reds, right? And the total now becomes, instead of 4 plus x, 5 plus x, it becomes 4 plus x. 1 less, right? So that means now you have 4 over 4 plus x. And this is given to you as 5 over 33. Does make sense to you? Clear? So that is how we are going to solve it. So there is no need to make a tree diagram if not specified. You could do it. Now I will suggest just simplify, cancel one of these 5s. You get 1 here and 1 there. Now we can just cross multiply, correct? So when you cross multiply, you get, or let me go one more step, okay? Sometimes it becomes too much if we do so many things in one step, which at a higher level you will be in a position to do. Is it okay? Yes, for sure. So now we can cross multiply. Okay. So 4 times 33 is equal to 5 plus x times 4 plus x. Clear? And now that is 4 times 3 is 12, 2, 1, 132, right? Equals to 5 times 4 is 20, 5x plus 4x plus x square. So we have a quadratic equation. Let's bring all the terms together. Writing x square first is a good idea. Plus 9x, and this we have plus 20 minus 132. Correct? So that is the quadratic equation which we are going to now solve. Let me rewrite this equation right there. So we have x square plus 9x. And how much is this? Minus, of course. So when you take away 2, and then when you take away 2 from this, you get 1, 1, 2 equals to 0. Right? So you get 112, and you have x square. You are now looking into product and sum. Right? So what could be the two numbers we could actually solve this question for you? So sometimes it becomes difficult to figure out. So what we do here is that we work with the number 112 and try to find its factors. So these are good techniques to learn, right? So for example, 112 could be 2 times what? So 2 times we could do 5, 56, correct? Now 56 could be written as 2 times what? 2 times 28, and that could be written as 4 times 7 or something like this. Correct? So in this fashion, what really happens is that we could actually get a kind of a tree, and that can help us to find a solution. Correct? We are looking for a product of 112. Of course, when you multiply these numbers, you'll always get 112, right? But what should you choose as your factors to get 9? So because this is negative, bigger number is positive, correct? So what could be that number? That is what you're looking for, correct? So if I have 4 times 4, 16, take away 7, does it make sense to you? I think it does. So if I choose these numbers, which is 16, right? So if I do 16 and 7, I do get 9. Perfect. So that is how I'm going to factor. This is kind of very critical step. So we can split 9x into 16x with the positive side minus 7x. You understand, right? Minus 112 equals to 0. I wrote this statement, but I could have written directly the factored form of this, right? So I could have written directly, but I'm going in steps just to show you how, because we have students of different difficulty level here, so that is why kind of important. So we have x plus 16 here, and if I take 7 outside, minus 7 outside, I get x. 112 divided by 7 should be 16, right? So we get plus 16 since the sign has changed. So the factor is x plus 16 times x minus 7 equals to 0. Now that gives you an answer which is minus 16, not valid. And that gives you an answer which is 7, is kind of valid because the value of x has to be positive, correct? So this is not valid, but this is okay. So we get the value of x as 7. And now we can write down our answer, which is, what is the value of x? So x is number of blue balls. X is equal to 7, right? Which represents the number of blue counters, right? Does make sense. So in addition to probability question, what we have learned here is also how to factor and solve equations. Now since the coefficient was 1, as soon as I got these two numbers, I could have written the factored form directly and got my answer, saved one step. However, I felt it important to show you this step also, since it is of great help to many students. So I hope that makes sense. So you must have noted by now that tree diagram is not a must. It is good to draw. Now if you don't have time really in your test paper, you could skip it many times, especially when it is not mentioned as it is in this particular example. Correct? Now let's take one more example. We are actually trying to understand what kind of strategy we should adopt to solve a given question. Here is a question based on independent events. Let A and B be independent events if probability of A is 1 over 4 and probability of A union B, that means A or B, is 2 over 3, then probability of B is what? You are given 4 choices. Now this is one of the most difficult questions in this series. Let's try to understand. When we are talking about two events, of course it is a compound probability, right? Now, second part is mentioned here, which is independent events. Now, compound and independence, what does that remind you of? That is what you have to think of, right? Now, if there are two events which are compound and which are independent, as given in this situation, then what is going to be the probability of A union B? This is what you need to figure out. And what is going to be the probability for A intersection B? Now, when I say union, it means what? It basically means that you're looking for probability of A plus probability of B, and there has to be something in common between these two also. That means you should take away the probability of A intersection B, correct? Now what is probability of A intersection B? Well, in case of independent events, the probability of A or B does not change from what has happened earlier, correct? It remains same. So in that case, probability of A and B is what? Is probability of A, and then B happens will be product, right? Probability of B. Even if it is other way, first B happens and then A, it doesn't really change. So I hope you got the concept here. Now in the given situation, we need to find the probability of B. I think these equations should help you to figure it out. So you can actually pause the video at this stage, write down the answer, and then look into my suggestions. So we could actually start with this particular equation. We are given probability of A union B, right? We are given probability of A. We need to find B. So we will begin with the union statement, right? So we are saying the probability of A union B is basically equal to probability of A plus probability of B. Take away probability of their intersection, right? So A and B, right? Okay. Now I'll be using this symbol a lot. Let's try to understand the symbol. This means what? This means or, right? And this means what? This means and. Right? Okay. So now I know probability of A union B. I know A. I don't know this and I don't know that also. But I have this formula with me, right? I can actually use this formula to help. Then I'll have only one type of variable, that is probability of B, right? So let's do that. So we can say probability of A union B is basically equal to probability of A plus probability of B, take away product of these two probabilities, right? Now you see very clearly that there is only one unknown here, and that is what we are interested in finding, so you can easily find it. Does make sense to you, right? So let's calculate this answer. So now we'll substitute the values. We know probability of A union B is 2 over 3. Probability of A is 1 over 4. Probability of B we need to find. Here we know probability of A is 1 over 4 and probability of B we need to find. So we'll rearrange and then solve. So we have 2 over 3 take away 1 over 4 equals to probability of B. We can take that as common, right? 1 minus 1 over 4. So that gives you, this is common denominator of 12. 4 times 2 is 8. 3 times 1 is 3. Probability of B. 4 common denominator. 4 minus 1. So probability of B is 8 minus 3 is 5. 5 over 12. And here we get what? 3 over 4, right? So times 3 over 4. So that gives us the probability of B as what? We'll just cross multiply, right? 5 over 12 is there. We'll multiply by 4, divide by 3, correct? You could simplify this a bit, dividing 12 by 3, right? And you get your answer, which is 5 over 9. Does make sense? So C is the right answer for you. Perfect. So that is how you're going to find the probability for B in the given condition. So I hope that helps. Now you could actually extend this question and you can find what is the probability of A intersection B, correct? You could do that. Perfect. Since you already know the probability of A and B, so that would be a good exercise. Here's another question from your practice test. There are 4 red counters and X blue counters in a bag. 2 counters are removed from the bag at random. The probability that both counters are blue is 1 over 3. What was the value of X? Clear? So you can actually pause the video now and then solve, correct? So this is exactly what we did earlier. So I'm going to actually write down the steps here without much explaining to you, but I think you should get it, right? So what we have here is we have red 4, we have blue X, and we have total, which is combination of these two, correct? So we've done the first statement. 2 counters are removed from the bag at random, so one after the other, right? So this is the case of without replacement. So it is dependent. The probability that both counters are blue. So we are saying that probability that we get blue after blue is 1 out of 3. Now what do you mean blue after blue? It really means that first probability for blue is there's only X blue, total is 4 over X. 4 plus X. The second time, and means product, 1 less blue, right? And 1 less of this. You could also write 4 plus X minus 1, which is same as 3 plus X, correct? So let's solve this. So we have 1 over 3. We have our equation now, right? So in the numerator, we have X times X minus 1. And the denominator, we have 4 plus X times 4 minus 1 is 3. So we get 3 plus X, correct? We can cross multiply. So we get 4 plus X times 3 plus x equals to 3 times x minus 1. We can expand this. 4 times 3 is 12, plus 4 plus 3 is 7x, right? Plus x squared is equal to 3 times x squared minus 3 times x. Correct? We can bring all the terms together, and then because 0 equals to 3x squared minus x squared, it's good to write like terms together. Is that clear to you? We get our equation, which is a quadratic equation. Let us take it on the right side and solve. So we have 3x squared minus, let me do 2x squared, right? Let's simplify this, like terms, right? So we'll just change the pen. So we'll combine these two and write down 2x squared, and then we have minus, these two means minus 10x, and minus 12 equals to 0. It is equality. I could write it on either side. You don't really have to change the signs, right? Well, 2 is common, so we'll take 2 common. So we get x squared minus 5x minus 6 equals to 0. It is very important to recognize that equation can be simplified. So why not, right? So now 6 times 1 gives you the answer. So we get negative numbers bigger, right? So we get this as the factored form. And clearly we have two answers, x equals to 6 or x equals to minus 1. Minus 1 is not valid. We are looking for something which is positive. So we get this as your right answer, correct? So our answer is, what was the value of x? X equals to 6. Is that clear to you? So it should not take more than a minute or two to solve such questions now. Is that clear? Perfect. Great. So let's take a small break now and see, and then let's continue. Thank you. So I went for a trek, and that was really beautiful. Saw a lot of deer on the way. So I shared that video with you. I hope you like it. Now let's continue and answer rest questions. We have 2 more questions to go. So this time again, here's a practice test question from your GCSE previous test papers. The question is, there are n counters in a bag. 4 of the counters are red and rest are blue. So in this case, we have red counters as 4 and the blue counters are n minus 4. Is that okay? And the total is n. Is that clear to you? So that is what is given in first 2 statements. Ross takes a counter from the bag at random and does not replace. So that is without replacement, dependent. He then takes another counter at random from the bag. The probability that Ross takes 2 blue counters is 1 over 3. Show that n squared minus 13n plus 30 equals to 0. Find the value of n. Okay, so let's work with this statement. The probability that Ross takes 2 blue counters, that means we're looking for blue after blue, right, is 1 over 3. And from here we should get one equation, and then that equation should be this. Well, that's a good hint. So let's try it out. You can actually pause the video at this stage, solve this question, and then look into my suggestions. So what is this probability of taking out blue first and then again a blue, right? So a blue first will be, there are so many blues, which is n minus 4 over a total of n, correct? Times, if I take 1, I got 1 less, right? So we get n minus 4 minus 1 blue. And here the total also reduced by 1, and that is equal to 1 over 3. Is that equation clear? Simple as that, correct? Perfect. So we could just cross multiply and complete our equations. 3 times n minus 4 times, this is what? N minus 5, correct? 1 less, right? So here we get equals to n times n minus 1. Let's open the bracket. N square will multiply by 3 later, okay? So we have n square minus 5n minus 4n plus 20 equals to n square minus n. Now let's open this bracket and we can actually combine these two also, right? So this becomes minus 9, correct? Both negatives, when you add them, minus 9. And when you multiply with 3, that becomes 27, correct? Okay. So we have 3n square minus 9 times 3, 27n, plus 3 times 20 is 60. Bringing these terms here will change their sign. So 3n square minus n square is 2n square. Adding 1n makes it minus 26n plus 60 equals to 0. 2 is common, right? So we have n square minus 13n plus 30 equals to 0. 2 cannot be 0. That means what? That means n square minus 13n plus 30 equals to 0. Is that clear? So that is how we are going to find it. Now, from here, we have to find the value of n. Perfect. So let's factor this. So we have the equation n square minus 13n plus 30 equals to 0. So we are looking for two numbers. 15 and 2 can work for us, right? So n minus 15 times n plus 2 should be equal to 0. That gives us n equals to 15 and also n equals to minus 2, which is not valid, right? So we know n is greater than 0, right? So this is not valid, but this is valid. So we get our solution, and the answer here is n equals to 15. Is that clear to you? Now, for some of you, let us say if you are unable to prove part A, it's not a bad idea to use that equation and find n. You get my idea, right? So at least you get part marks for B. So that is also a very important thing to understand whenever you're solving questions in a test paper. Everything counts. Perfect. Now let's take the next question. Now this is from GCSE test papers. The question here is, there are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. Simon is going to take at random 2 pens from the box. The probability that Simon will take 2 pens of the same color is 27 over 55. Work out the number of green pens in the box. So here we have 2 types of pens. We need to figure out how many of these are in the box. So to begin with, we have, let us say, G green pens, right? So G are green pens. So there are 3 more blue pens than green pens. That means the blue pens are G plus 3, right? So 3 more. Now we are given Simon is going to take at random 2 pens from the box. The probability that Simon will take 2 pens of the same color. So we are looking for same color, right? So it could be either 2 greens or 2 blues, right? So same color is 2755. Work out the number of green pens in the box, correct? So now, so when we say probability for same color, okay. When we say probability of the same color, in this case, it could be both green or both blue, right? So that is what we're looking for. So we know number of green pens are G, number of blue pens are G plus 3. Total number of pens are how many? total number of pens are G plus 3, which gives us 2G plus 3. Correct? Now, when we're talking about both green or both blue, then let's work out their probabilities, and OR means we have to add them up, right? So probability for same color will be so when you say both green, that means first is green and second is also green, correct? When we say both blue, means first is blue and the second one is also blue, correct? That's what it means. So first is green. There are G greens, right? So that means the probability will be G divided by total. Total will be 2G plus 3. Now, so picking up green first will be this probability. Once a green pen is picked, there is one less green pen. So the probability now reduces to G minus 1. The total also reduces by 1. So it becomes 2G plus 2, right? Now let's talk about blue pen. Now for the blue pen, if blue pen is picked first, in that case there are G plus 3 pens. So we say G plus 3 and total is 2G plus 3, right? Now if one pen blue has been picked, one less is there, so we have G plus 2 available, and in the total also one has been reduced, so we have 2G plus 2. So that becomes the probability, and what we are given here is that this probability is basically equal to 27 over 55. So that forms an equation, and in this equation there is only one unknown G, so which we can actually find. Perfect. Now let's see how to calculate G. So we have a common denominator, which is 2G plus 3 times 2G plus 2. In the numerator, we can multiply and expand. So we get G square minus G from these two terms. And here we get G square. 2G plus 3G gives us 5G. And 2 times 3 gives us 6. And that should be equal to 27 over 55. Now we can simplify it slightly more, combining 5 and minus G and adding 2 G's. So we get 2G square plus 4G plus 6. G is number of green pens divided by 2G plus 3 times 2G plus 2. And that gives you 27 over 55. Now one way to calculate the value of G, of course, is to cross multiply, and then you'll have a quadratic equation to work with and get your answer. The other way is to kind of guess and check, right? Now it's a very educated guess and check. Now if I look into this fraction, we could write an equivalent fraction, because 55 we have only two multiples, 5 and 11. But here in the denominator, what you notice here, the difference in the two numbers is by 1, right? So this is 2G plus 3 and this is 1 less. So we're looking for denominator to be product of two consecutive numbers, right? So these two are consecutive numbers. Do you see that? 2G plus 3 and 2G plus 2 are two numbers which are consecutive numbers, one after the other. 55 you cannot get as a product by two consecutive numbers. But if I multiply both by 2, then what do I get? 2 times 5 is 10, we get 110 here. And multiplying 27 by 2, I get 54. Now, I could write 110 as 11 times 10, Do you see that? So that really means that 2g plus 3 could be 11 and 2g plus 2 will be 10. I have to check if the numerator gives me 54 or not, right? So let's check it out. So the numerator, let's substitute the value for g equals to what? Now let me work on this side, right? So we have hint that 2g plus 3 is 11, or we can say 2g plus 2 is 10. So let's work with 2g plus 2 equals to 10. So that gives us 2g equals to 10 minus 2, which is 8, and g is 8 over 2, which is 4. Now if I substitute 4 here in the numerator, what do I get? Let's do it in a different ink. So we get 2 times 4 square plus 4 times 4 plus 6. Now 16 plus times 2 is 32, plus 4 times 4 is 16 plus 6. Now that gives you 54, correct? So it matches with 54, and the denominator also matches. That means what? So we have found our answer, and the answer here is that the number of green pens is basically equal to 4. Correct? So now we know that if green pens are 4, then the blue pens are 7. And if you place the value 11 as the total, you can see that the probability of getting both green, or both of the same color I should say, is 27 over 55. Does make sense to you, right? So that is how this question can be solved. The question here is, a jar contains 2 red, 1 blue and 1 green bead. 2 beads are drawn at random from the jar without replacement. So that's kind of important. Without replacement. Draw a tree diagram to illustrate all possible outcomes and associated probabilities. Find the probability that a blue bead and a green bead are drawn from the jar, right? So let us carefully look into what we are given, right? So we are given 2 red. We are given just 1 blue. And also 1 green. So what is the total? Whenever we're talking about probability, it is very important to understand what is the total. Right? That is your denominator most of the time. Now 2 beads are drawn at random. So what we will assume here is one after the other. So when we are saying 2 beads are drawn at random, we'll say one after the other. So it involves 2 steps, right? So in step number 1, for example, you could draw either color. So in step number 1, let's begin from here, you have 3 combinations. So you could get a red, you could get a blue or a green, right? Now since there are 2 reds, what is the probability of getting a red? So 2 reds out of 4 means 2 out of 4, correct? Only 1 blue means 1 out of 4, and for green also it should be 1 out of 4. So that part is clear. Now again, you make a second attempt. So when you do the second time, then also you got these possibilities. So what do you get? You get 3 possibilities once again. Now look here for the nomenclature which we are going to do. Now let us assume that this time we are getting red again, right? We could get red, we could get blue or green also. Let's write down blue and green also. Now what is the probability of getting the second red? Since 1 red has been already withdrawn, it is without replacement, so we are left with only 1 red. And 1 number less means the total now has become 3. So this is 1 over 3. Now in the first draw, it was red, not blue or green, so still we have these 1 each. So their probability is also 1 over 3 and 1 over 3. Clear? Now when it comes to blue, then again you could get any of these combinations, correct? Let me make 3 and then we'll discuss. So you could get red. Since in the first row you got 1 blue, that means we have got 2 reds here. 2 reds out of 3, right? So 2 out of 3. Now, can I get blue? Well, I've already got a blue and there was only 1 blue. So basically that is 0, right? So it is 0 over 3. There is no possibility of getting blue now since we never replaced it, right? How about green? There is 1 green since we have only taken out a blue, in this case, so 1 over 3. Is that clear? Correct? Now let's talk about the green. So here again, now you can realize that you cannot draw green, right? So I'll make a small green here. However, we know we could get a red or a blue. So we could get red or a blue. Since we got green the first time, there are 2 reds with us. So this probability is 2 over 3 and still 1 blue, 1 out of 3. And for green, it is 0 out of 3. Correct? So I'm not rewriting green, but I know. That's it. So we got our tree diagram with the probabilities. So with that, we have done the first part. Kind of. We actually should have a combination here also to really complete it. So let's look into these combinations also. Right? So, okay. So here, what are we saying? We are saying that what is the probability of getting red once we know we already had red? That is what we are saying. We get red once we know we already have red, which is 2 out of 4 times 1 out of 3. Is that clear? Now similarly, you can read the others. So this is probability of B, the blue, when we know we already got red, right? So here again, it is 2 over 4 times 1 over 3. Now in this case, it is probability of green when we know we got red earlier. So we get 2 over 4 for the red and 1 over 3 for the green. Now in this particular case, let me use a different ink now since this is going to be very congested. Okay, so we're talking about probability of red when we know that we got blue earlier is 1 out of 4 times 2 out of 3. Now this is 0, so we'll not write this. Probability of green when we got blue earlier is basically 1 out of 4 times 1 out of 3. In this case, we get 2 probabilities. We cannot get green again, right? So we get probability of red when initially it was green, and that is 1 out of 4 times 2 out of 3. The last one here is probability of getting a blue when the first one was green and is 1 out of 4 over 1 out of 3. Is that clear? So you could always simplify and write a number there, but for understanding, this is a better format. Now, let's look into what they are asking for. Part B. Part B is find the probability that a blue bead and a green bead, right? So we want blue and a green. So either one could be first or second, correct? That's what we want. So in these combinations, wherever we have blue and a green, so we'll forget about the red line. We'll see the blue and the green lines. So blue and the green, we get this one, that is clear, right? Or we could get green first and then blue. So these two, right? So that is the probability for, I should say, blue. Let me combine them like this. Or means union green. Okay, so that is what we're trying to figure out. So we can just add them up. So it is 1, this one green after blue is 1 out of 12. And we are going to add blue after green, which is also 1 out of 12. So we get 2 out of 12 or 1/6. So the probability for this case is 1 out of 6. Is that clear to you? And that is how we are going to figure it out. Now here is another interesting question from my list of videos, and I hope that will help you to understand this topic even better. So by now we have seen how to solve most of the questions which were there in your practice test or previous tests, and also combined with some from my list should give you good confidence. So here is the very last question. Let's see if you can solve it. The question here is the probability that a student like math is 0.6 and the probability that a student like English is 0.2. We're saying probability for math. So let's say this is liking math is 0.6 and probability for liking English is 0.2, right? If only 1 in 10 students like both math and English. So both means probability that math intersection, that means both, is it okay, is 1 in 10. So you could write probability also as a fraction and also as a percent or decimal, as we have seen, right? It says if only 1 in 10 students like both math and English, what is the probability that a student chosen at random does not like math or English? So what do we need to find? Does not like math, so it is does not. That is where the complement comes. Do you understand? So that is where the complement, right? So complement here means does not, right? So that we'll say M with a bar, that means not maths. Do you understand? So let's read. So it says, what is the probability that a student chosen at random does not like math or English? Or means union, right? Or English does not like. This is what we have to figure out. Is that clear to you? Perfect. So that is how this question is slightly different from what we worked out, right? So initially, I hope you remember when we talked about complements, so we said something like this, right? So complement means outside, not in it, right? So everything outside. So that means 1 minus. You get the idea, right? So what it should be like this. We are given probability of liking maths. So probability of not liking maths will be what? 1 minus 0.6, which is 0.4. Probability of not liking English will be what? 1 minus 0.2, which will be 0.8. Do you understand? So that is what we are trying to say, right? So similarly, what is the probability of this intersection? Well, this is 0.1, right? So 1 minus 0.1, which is 0.9. Correct? Since 1 over 10 is what? Is 0.1, correct? You get the idea, correct? So that is kind of important to understand. And now I think we can continue and answer this question. So what do we want? We want the probability of student chosen at random does not like math or English. Does not like math or union, or means union, right? Union English. So that basically means he does not like math, right? And he does not like English. We have counted those who like, intersection twice. So we have to take away the intersection of this, right? Since that has been counted twice, right? So that means what we get here is 0.4, 1 minus this, right? Plus this 0.8 minus 0.9. Do you see that? So we had already figured out these numbers. We can use these numbers here to get our answer. Does it make sense to you, right? So we have when you take away 0.9, you get 1 less, 0.3 as our answer, correct? So what is the probability? So we say probability of not liking math or English is 30%. You could say that, which is the meaning of 0.3. Does it make sense to you, right? So I hope you enjoyed the whole series where we have taken a couple of examples. It must have taken about an hour, but it's worthwhile. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. I'll also provide you with link of videos which will be very helpful for students who wants to do A plus higher level, university level courses. And there we are also talking about minimum and maximum values using Venn diagrams. Those are challenging questions which will be of use to many of you. Thanks for your time and all the best.
Not of them with the dolls because they're in Halifax right now and they've got dolls at home. This is the website. They're really nice dolls. They're very well. You can like keep them for like generations kind of thing. I got Noah the fox. And I got Sophie. Of course, everyone. So funny. She has to be very jumpy. So this is the uniform. Yeah, I'm sure I got her this one though. I remember Ella. And then I got, where's the fox? I like the fox. I was torn between. Actually, his favorite animal was something like a penguin or something, and I didn't have a penguin, so I was like, oh no, not a penguin, something else that I didn't find.